For the first several years of their existence, large language models were effectively answering machines. You typed a prompt, and a system like GPT-3 generated text in response. The entire interaction was sealed inside a closed loop. By 2021, these models had ingested enough of the internet to explain exactly how to book a flight, navigate a file system, or write a SQL query to pull data. But they lacked the capacity to actually buy the ticket or run the code. This limitation came from the architecture. The models were quarantined in a text-in, text-out environment. It was cut off from the external digital web, without access to browsers or APIs. The intelligence to execute complex tasks was present in the network weights. The models mapped out correct steps, but bumped right against an engineering barrier preventing action. Building a system with a higher parameter count wouldn't solve this. The engineering challenge shifted from training smarter text generators to building the scaffolding required for those models to interact with the world. In 2022, React proposed a loop. Instead of generating text, the model alternates between reasoning and acting. It generates a thought, triggers a tool, and waits. The tool returns an observation, like Tokyo's population, fed directly back, grounding its logic in hard facts. Months later, researchers at Meta published Toolformer, demonstrating that tool use didn't have to be forced by an external script. It could be learned. The model was trained to pause during its own text generation and evaluate its own knowledge gaps. It developed a meta-level judgment, weighing the computational cost of interrupting its output against the benefit of calling out to an external calculator or calendar. The system stopped passively predicting the next word based purely on memory. It actively interrogated external services to acquire the information it knew it was missing. By June 2023, this capability crossed from academic labs into commercial infrastructure. OpenAI updated the API to include function calling. Function calling replaced messy workarounds with a strict standard. Diverse APIs and databases are now wrapped into structured JSON data, allowing the model to execute commands with predictable syntax. Within months, this pattern propagated, becoming the default blueprint to connect AI systems to digital environments. Anthropic integrated this standard, ensuring their models could reliably trigger external commands. Google adopted identical infrastructural mechanisms for their Gemini architecture. This standardized infrastructure for tool calls enabled developers to compose specialized AI roles into broader architectures. Systems began using an orchestrator agent to coordinate researcher, writer, and critic agents toward a single, unified objective. These multi-agent patterns, popularized by frameworks like AutoGPT, began attempting to navigate code repositories and perform data analysis autonomously. While reliability remained a challenge, the role of the model began to shift from generating text to coordinating digital workflows. An AI system that plans its own steps, observes the results of its actions, and modifies its behavior to reach a goal functions as an autonomous actor. This introduces systemic vulnerabilities. In a multi-agent pipeline, an error made early compounds rather than self-corrects. Because agents share context, a single flawed assumption from a researcher agent cascades. The critic validates the bad premise, forcing the network to confidently pursue a wrong answer. The stakes of those errors scale directly with the system's agency. A hallucination in a text chat can be ignored, but an agent instructed to clean up a database or email a client executes real-world actions that are strictly irreversible. This permanent nature of real-world execution forces a sharp pivot in AI safety protocols. The focus moves out of the theoretical realm of aligning what models say and directly into aligning the actions they take. Engineering teams are now implementing strict minimal footprint rules, granting models only the exact read and write permissions necessary for a specific task. They are inserting hard human-in-the-loop checkpoints, where an agent must pause and request authorization before hitting send. The structural barrier between intelligence and agency is gone. The models have hands. The defining engineering question is no longer how to make an AI system act, but under what exact conditions it should ever be authorized to do so.